Everything you have ever been taught about Uranus came from one afternoon. Not decades of study, not a fleet of orbiters, one spacecraft, one pass, one narrow window of hours. And for almost 40 years, that single window has been treated as the truth about an entire planet. New evidence says the spacecraft may have arrived on the one day that would lie to us. That matters more than it sounds like it should. Ice giants like Uranus are not some rare oddity in our solar system. Current surveys suggest they are the most common type of planet in the entire galaxy, more common than worlds like Earth, more common than gas giants like Jupiter. Almost everything astronomers assume about that class of planet, anywhere in the universe, traces back to what we think we learned about Uranus. If that foundation was built on a bad day, the crack runs a lot further than one blue-green planet at the edge of our own system. In 2024, planetary physicist Dr. Jamie Jasinski at NASA's Jet Propulsion Laboratory led a team back into that old data set, not to collect new information, because there isn't any, but to re-examine what we already had. What they found, published in Nature Astronomy, quietly rewrote the story of the only up-close visit humanity has ever made to Uranus. That visit was Voyager 2 in January 1986. The spacecraft's closest approach lasted only a matter of hours before it was gone again, hurtling on toward Neptune and then out of the solar system entirely. Think of it like judging an entire country's climate from a single afternoon photograph, taken unknowingly in the middle of a freak storm. That's essentially what Voyager 2 did at Uranus. And nobody knew it was a storm until 2024. Jasinski's team looked at the solar wind conditions in the days before Voyager 2 arrived and found that pressure from the sun had spiked dramatically right before the flyby, compressing Uranus's magnetic bubble down to a fraction of its normal size. That single coincidence explained decades of confusion, why Uranus's radiation belts looked unnaturally intense, and why its magnetosphere appeared almost completely drained of plasma. The mystery, it turned out, wasn't really about Uranus. It was about weather. That should have settled it. It didn't. Because if the magnetosphere was squeezed empty that day, then the missing plasma has to have come from somewhere. And the leading candidate is Uranus's own moons. For 40 years, textbooks describe Uranus's 5 major moons: Miranda, Ariel, Umbriel, Oberon, and Titania, as small, cold, and geologically dead. Too little internal heat, the thinking went, to do anything but sit there. But if Voyager 2 caught the system during a rare compression event, the empty magnetosphere it measured may simply reflect plasma being pushed out of the system that day, not the absence of moons quietly venting material into space the rest of the time. In other words, those moons may have been geologically active all along, and the one snapshot we've just happened to catch them looking dormant. That would be strange enough on its own. But it's not the only place Uranus has been quietly rewriting itself. Uranus should not be the coldest planet in the solar system. It sits closer to the sun than Neptune does, which means it receives more sunlight, which means by simple logic it should run warmer, but it doesn't. Its cloud tops hold the record for the coldest temperature ever measured on a planet in our solar system, deep enough to make dry ice look mild. And in observations made between January 2025 and 2026, the James Webb Space Telescope confirmed something researchers had suspected since the 1990s. High in Uranus's upper atmosphere, the temperature has been dropping for 3 decades and still hasn't stopped. Webb measured it at roughly 150 degrees Celsius up there now, scorching by human standards for that thin, high layer of air, but colder than anything ever recorded at that altitude before. Nobody has a settled explanation for why a planet would keep cooling, decade after decade, with no sign of leveling off. You'd expect Webb's data to finally start clearing things up. It didn't. It made things worse. Alongside the cooling trend, Webb measured the density of charged particles in that same upper atmosphere and found it roughly 10 times lower than existing atmospheric models predicted. That's not a rounding error. That's a sign the working models scientists have used for ice giants for years aren't slightly miscalibrated. They may be fundamentally wrong. And underneath all of it sits the strangest fact of all. Every other giant planet in our solar system radiates more heat from its own interior than it receives from the sun. Uranus, for decades, appeared to radiate almost none. No internal engine, no leftover warmth from its own formation. The leading explanation, sometime around 4 billion years ago, at least one planet-sized impact slammed into Uranus, tipped it onto its side, scrambled its interior, and shut its heat engine down, cold, dormant, ever since. Except a 2025 reanalysis of Uranus's full energy budget found something nobody expected, a faint, statistically real trickle of internal heat after all, a fraction of what Neptune produces, but not zero. The planet that supposedly stopped generating its own warmth 4 billion years ago may never have fully gone quiet. Think about what that actually means for a second. We are not talking about a forgotten rock at the edge of the map. We are talking about the template for the most common type of planet in the Milky Way. And our entire understanding of it rests on hours of data from 1986. A handful of models we now know are significantly off, and a fresh set of questions Webb only opened rather than closed. NASA's proposed Uranus orbiter and probe, the mission built to finally go back and check all of this properly, would not arrive at Uranus before 2049 at the very earliest. And current budget and trajectory studies suggest it could slip later still. Voyager 2 flew past in 1986, 63 years, minimum, between the only two close looks humanity will have ever taken at this planet. Somewhere out there, orbiting a star we haven't named yet, there is very likely a planet just like this one. Cold, tilted, quietly generating heat nobody predicted. And the only reference point we have for understanding it is a 5-hour photograph of a planet caught by pure chance on a very bad day.